How are you, my dear students? For working into this exercise, what you're going to do is definitely just as always, read the exercise carefully, and then you're going to just pay attention to the rest of the part. If you really did this part, so then it's good for you because you're confirming what you were doing was right or a little bit. Well, first of all, balance the reaction. I gave you the reaction. You can use any online balancer, which is really easy to do. And you put that everything. If not, you balance it at home. It will take a little bit more time, of course, in this moment, since we're in this using all of the tools we've got, then they use the internet in your benefit. So at first, you just read the data and stuff. 40% alcohol by volume. Ethyl alcohol, I gave you the formula. Density is this one. Density is grams over milliliters. It says there. And what's the minimum of mass of HCl? So it's asking for mass of HCl at the end. And to destroy the alcohol in 2 liters of vodka. So what are you going to do in the first place? First of all, what you need to do is underline what you're going to relate. This is not limiting reactant or stuff like that. It's something a little bit beyond because you're using percentage there. In the first place, since you have some of the alcohol there, and you have it specifically this 2 liters of vodka, then you must convert that first, right? So the 2 liters of vodka to the specific amount of alcohol you've got, because vodka is a type of alcohol, but some alcohol is submerged it or just diluted that. If you pay attention to that, we're going to get started with the conversion. 2 liters of vodka, right? 2 liters of vodka, right? Vodka. Good. And then you do the conversion. That in 2 liters of vodka, it says that 40% by volume. So what's the 40%? 2 liters of vodka is the 100%, right? 100%. Okay. So 40% would be what specifically? Say what I mean? 40% would be what? That is your X, the one you're looking for if you're doing some conversion factors or stuff like that. If you're doing, sorry, reglas de tres, or you can work on this. So 40%, which is the 40%, right, of vodka, since I know that the conversion factors in the lower case, you put 100%, we know it is, what will be the 40%? Knowing that the 100% is the 2 liters of vodka, right? 2 liters of vodka. Vodka is the 100%, but 40% is the alcohol in there, okay? And then we continue with the conversion factors. So you just open the conversion factor and then do the fraction to the fraction in there and continue with doing your conversion factor because it's a little bit, right? And then we continue. So once you have in here, you have in the 100% of vodka, 40% is alcohol. Good. Then you're going to have the value of the alcohol, but it's going to be in liters, right? If you do that, you're going to see that. Let's try to find what you obtained, right? 2 liters, then you copy that and you put equals and stuff like that. And it's going to be 40, right? Times 2, 40 times 2 divided to 100, 0.8. So then 0.8 liters of alcohol, right? So the real alcohol you're having there is 0.8 liters, right? Equals 0.8 liters of alcohol. That's something important there, okay? So you have that one for real. Now, how much what's the minimum mass of HCl to destroy that amount of alcohol? So 0.8 liters, you're going to find in 2 liters of vodka. So it's strong. 0.8 liters of real alcohol in 2 liters of vodka. That means the rest could be the amount of the beverage from the potatoes they use for making vodka and stuff like that. But the 0.8 liters are real alcohol for drink or the drinkable ones and stuff like that. Okay, if you understand that part, we continue with the following, which is the, also you have the density for alcohol. Why is that? I already have the 0.8 liters of alcohol, so I must transpose that one to grams of alcohol because I have that. So let's transform that. Let's get started to work. 0.8 liters of alcohol, right? Right? And let's pass it first of all to milliliters because they're the ones of a milliliter. So I know that 1 liter of alcohol is 1,000 milliliters of alcohol. And then also then milliliters of alcohol, you have it in milliliters. And also it says there in the conversion I gave you in the data, it says that you put milliliters in the lowercase. It says that in 1 milliliter of alcohol, you use that conversion, you have specifically, it says 0.7893 grams of alcohol. See what I mean? Right? And then you continue with the conversion factor. And also, you know, you can do you know that in one, let's pass it to moles. In 1 mole of alcohol, which alcohol? What is the alcohol? The C2, H5OH, that is alcohol. So I'm going to write it in formula instead of just writing the word alcohol. In 1 mole of alcohol, you have 12 grams from carbon times 2 equals that plus 5 grams from hydrogen, plus 16, and plus 1 another hydrogen. So it says it's 46 grams of alcohol. See what I mean? Alcohol is C2H5OH, so no reason to be confused. And then also my reaction says, and you continue with the relationship, that 3 moles of alcohol, 3 moles of C2H5OH, got it? Are related specifically with 12 moles of HCl, right? 12 moles of HCl. And also, because it says, what is the minimum mass? So then we're looking for grams, and then let's pass it to mass. Then definitely 1 mole of HCl, what is the mass? Then you add the mass of chlorine, 35.45. 35.45 plus 1 from hydrogen, it says 36.45. 36.45 grams of HCl, and that would make it. So then you have it. Then you use the, as I said, I'm just going to write in here the divisions so you don't get confused. What is that, Mr. Victor and stuff? And then those are just conversion factors, conversion factors, conversion factors, conversion factors and stuff. Remember, what I just said is that alcohol is C2H5OH, so that's why I didn't write the formula. I prefer to use the word and stuff like that. It's basically the same thing. So liters of alcohol, I passed it to milliliters, and the milliliters of alcohol to grams of alcohol, then the grams of alcohol to moles of alcohol, then the moles of alcohol to moles of HCl, and the moles of HCl to grams of HCl. At the end, what's going to be the answer then is going to be a little bit, you do that 0.8 times 1,000 times 0.7893 times 12 times 36.45, all of that divided to open parentheses 46 times 3 and close parentheses, right? And it's going to give you specifically 2001.39 grams of HCl. Okay, so basically that would make it, my dear students. Hope you got it, and that's it.